Next, I want to go over a couple of special factoring patterns that we may run across. The first is a sum of two cubes. So this would be something in the format of this is a perfect cube here, this is a perfect cube here, and we have a plus sign between them. So we are taking the sum of two cubes. If we have something in this format, then instead of going through a method like our Xbox method or something like that, we can immediately write the factored form using this equation, a plus b, and then a squared minus ab plus b squared. Let's look at an example of that. So if we look at 64x to the third plus 1, 64 is the perfect cube of 4. X cubed is the perfect cube of, well, x, and then the perfect cube of 1 is 1. So we can use this equation. We're going to rewrite this showing what the perfect cubes are. So we will rewrite 64 as 4 cubed. X cubed will become an x on the inside and a cubed on the outside. The cubed on the outside means take this cube and multiply 4x by itself 3 times. Finally, 1 cubed would be our second term. So our a term is 4x, this is our a value, and 1 is our b value. So everywhere that I see an a here, I'm going to plug in 4x. Every time that I see a b here, I'm going to plug in a 1. So let's see what that looks like. The first thing is an a, I put in a 4x. Next is plus b, so plus 1. A squared, well, 4 squared is 16 and x squared is x squared, minus a times b. So I have a 4x times a 1. That's going to give me a 4x, and remember the minus sign here. And then finally 1 squared, because b is 1, so 1 squared is 1. Difference of two cubes is similar. Just notice that because there is a negative sign here instead of a positive sign, we have a opposite sign here. We have a negative here, and the negative that we had here becomes positive. The plus b squared is common to both of these. That is always going to be a positive there. Let's look at an example. 27x cubed minus 8. 27 is the perfect cube of 3. And then we have an x cubed, so we can write this as 3x, and that is our a term. And then 8 is the perfect cube of 2, so that is going to be our b term. And now we simply plug in just like before. 3x everywhere I see a, and 2 everywhere I see b. So I have 3x minus 2 to account for a minus b. 9x squared is 3x, and then square it, so 3 squared is 9, and then x squared. A times b is going to be 3 times x times 2, 6x, and then finally 2 squared is 4.